All right, here we go. So we have a 10-foot ladder leaning up against a wall. So we put the 10 into the picture because that's a fixed number. So let's get some arrows going of what's happening. The top of the ladder is sliding down, so I'm going to put a letter here, and they tell me at 2 feet per minute. So we do not put the 2 feet per minute in that picture. What we want to do is we want to label that side as y and say that dy over dt is 2, and not just 2, but -2, because that length of y is getting smaller. Okay, so what else do we give in here? When information. So when the top of the ladder is 8 feet, so that means when y equal 8. Remember, save that until after the derivative. How fast is the bottom of the ladder sliding away from the wall? So that's an x, and I want to find dx dt. So we've got 3 of the 4 things that we need. So we have the given rate, the find rate, the when information, and now I'm going to get the equation. I see Pythagorean. X squared plus y squared is 10 squared. So now we're ready to take the derivative with respect to t. So it's 2x, and remember you have to use dx over dt. You cannot use x prime or y prime here in this case either. Equals 0, and be careful you put 10 squared as 0, right? So then I'm going to cancel the 2's, and I'm going to see what I have to plug in. So I have x, don't know what that is, so I'll just carry that along. Dx over dt, oh, don't know what that is yet. Oh, but that's what I'm trying to find. So that's totally legit to have it there. And then I've got y, I can plug the y as 8 in, and the dy over dt, oh, I know that that's -2. And all of that equals 0. So I'm on a mission to find x, because this is my goal to solve for this, but I need to find out what x is. So this is where I plug my when information into my original equation. So let me make some room right here. So I'm going to have x squared plus 8 squared is equal to 10 squared. So that's x squared equals 100 minus 64. So you know, let me make some room. That means that I get x squared is 36. So x is plus or minus 6, but we know because we're dealing with the physical length, this length here is going to be 6. So if I solve for dx over dt, I would subtract this over, so that would give me a positive 16 over 8. I'm sorry, over 6. Over 6. That's a fine answer. All right, let's look at this next one. We want to find out when the particle is speeding up and slowing down. So there's 2 graphs that I need. I need the graph of the velocity, and I need the graph of the acceleration. So let's first find the velocity, which is one derivative, right? 3t squared minus 6t. And then I'm going to, I did mention in the notes that I always make these easy to graph. So I'm going to factor out a -3t, and that will give me a t plus a 2. And then I know it's upside, well, actually, I'm going to change that. I'm going to make this equal, and I'm going to keep the, maybe it could be easy. I just want thinking of which is easiest to be able to graph it. So if I just factor out a 3t, I'd get a -t minus a 2. Oh, it's about the same, I guess. Doesn't matter. Okay, so I know that it's going to cross at, oops, that's what my problem is. Should be a plus there. Okay, so that's a -t plus a 2. So this here is 0, and this here is 0. So that means the root is 0, and the root is 2. And I know it's an upside down parabola, right? Okay, so that's my velocity. Crosses here at 0 and crosses here at 2. My acceleration, I'm going to go to this equation here to find it. So I get a -6t plus 6. So if I'm to graph that line, cross y-intercept of positive 6, -1 slope, -6 slope, and it crosses here at 1. Okay, so I'm going to draw this graph in a different color. So you can see here's 1, right? And then if I was to look at this graph, this crosses here at 2, right? So there's 2. So now I'm going to go and compare signs. So I know that it's speeding up. Let me make some room above here. It's speeding up if both velocity and acceleration have the same sign. They're both positive or if they're both negative. So let's look. I'm just going to look at their graphs to figure that out. So speeding up. So, and I'm going to have slowing down. So if I'm looking between 0 and 1, this graph is positive, and this graph is positive. Oh, so since they have the same sign between 0 and 1, the particle is speeding up. Let's go to the next interval. Between 1 and 2, this graph is positive. Between 1 and 2, this graph is negative below the x-axis. So that means between 1 and 2, it's slowing down. Going to the next little interval, if I look after 2, this graph is negative. After 2, this graph is negative. So that means it's speeding up from 2 to, oh, and it doesn't say infinity. It says only go to 5. So from 2 until 5, it's speeding up. All right, last one, find the distance covered. So we can always find out where it starts by plugging in times 0, so that's 7. And I can find out where it ends by plugging in at 4, so I get 64 minus 3 times 16 plus 7. So I'm going to get my calculator here. So well, so I get 64 minus 48 plus 7, and that gives me 23. Okay, so that's the beginning and the ending point. So what's necessary to do next is to find out when the velocity is 0, because that's a point where it changes direction, and we probably will find one in between time 0 and time 4. So let's go do the derivative. So v of t, which is the derivative of this, 3t squared minus 6t. All right, so let's set this equal to 0. And you know, never divide through by things. If I can factor out a 3t, so I get a t minus 2. So I get t equals 0 and t equal 2. Well, I've already used t equals 0, right? So I'm interested to find out where it's at time 2. So s of 2 gives me, and I'm putting it back into here, 8 minus 3 times 4 plus 7. So 8 and 7 is 15, minus 12 is 3. Okay, so now let's draw this. So let's talk about what numbers actually go on the number line. This number 7, this number 23, and this number 3. Those are the ones that go on the number line. So I'm just going to put them 3, 7, 23. Okay, so now let's identify where the times. So there, it's at 7 at time 0, and then it moves to this point of 3 at time 2, and then it goes over to here at time 4. So it goes here to here. So now the distance is the actual number of footsteps covered. So the number of footsteps between here and here, well, that's 4 footsteps, right? And then the number of footsteps between here and here, that would be 20. So there'd be 24 units covered.